welcome to my channel. My name is Sevim and we are practicing AWS together. If you have seen my previous videos, today we are going to practice on AWS Educate, and this is going to be Builder Lab session, and I'm going to start with let's see the modules. There is Security Basics, Amazon Cognito Primer, Amazon AWS Cloud 9, Cognito Lab, Database Basics. We are going to do all this together, but I'm going to start with the first module in this video, and you can follow for the next ones in my next videos. Amazon DynamoDB, Microservices and Serverless, AWS Step Functions Primer, and this will be it for this lab. So we are going to practice, and I see on the security basics it's not reading it out loud, and I'm going to read that one so I can watch the video and repeat my practices as well. And if you would like to study as well, you can go to AWS Educate. You can follow my playlist, and in my playlist I will link all the sessions. You can go through them and we can study together, and you can do your lab sessions, and if you get stuck somewhere, you can follow and see how I'm doing. We are going to learn together. And this is Security Basics, Introduction to Objectives. I'm not going to read this part, but I'm going to read next ones. This module will give you an introduction to security basics, including the following: security principles, shared responsibility model, security terminology. It's good to repeat shared responsibility model, because sometimes I just feel like sometimes if I don't repeat, I get confused. It sounds simple in the beginning. That's so clear, that's logical. But when I receive an answer, I receive a question, final assignment or something, then I kind of get confused. Okay, let's start with security basics. In the cloud, there are a number of principles that can help you strengthen your security. The next several slides discuss the principles which can help guide the conversation around security and compliance. First, we will learn about apply the principle of at least privilege. Second, enable traceability. Third, security all layers. Fourth, automate security. 5, protect data in transit and at rest. 6, prepare for security events. 7, minimize the attack surface. So let's start with the first one. Apply the principle of least privilege. An organizational security culture should be built on principles of at least privilege and strong authentication. Grant authentication. Grant access to data and other resources to only the people who really need that access. By default, all access is configured as an implicit deny. You can grant access to specific entities as needed based on each job role. Enforcing a separation of duties with appropriate authorization for each interaction with AWS resources is a security best practice. You should set expectations regarding how you will delegate authority down through software engineers, operations staff, and other job functions involved in cloud adoption. By centralizing privilege management and reducing or even eliminating reliance on long-term credentials, you can diminish your attack surface area. Okay, it's also for some, for example, if you are working on accounting, you may not need to see logistics part, or let's say not logistics, or like other departments like finance or sales, you may not need to see them for each part of your department. And the second one, let's go to the second one next. Enable traceability. With AWS, you can monitor, alert, and audit actions and changes in your environment in near real time. AWS provides native logging and services that you can leverage to provide greater visibility in near real time for occurrences in your environment. You can use these tools to integrate into your existing logging and monitoring solutions for end-to-end resolution of security-related activity. Knowing what workloads are deployed and operational allows you to audit and ensure that an environment is operating at the security governance levels expected and determined by the security standards. Okay, let's go to the secure all layers. Rather than focusing on protection of only a single outer layer, apply a defense in-depth approach with other security controls. This means applying a security to all layers, such as your network, application, and data store. For example, you may require users to strongly authenticate to an application, In addition, confirm that users come from a trusted network path and require access to the description keys to process encrypted data. One of the benefits of using AWS is that AWS services are also built for integration. You may use several AWS services together to provide the most secure environment for your data and resources. So, automate security. Fourth one. Yes, at AWS we purpose build security tools, which gives us the ability to automate many of the routine tasks that security experts normally spend time on. Using infrastructure as code and comprehensive set of application programming interfaces like APIs and tools, you can automate security engineering and operations functions. You can also fully automate and deliver identity management, network security, and data protection and monitoring capabilities by using popular software development methods that you already have in place. Rather than having people monitoring your security position and reacting to an event, automation gives your system the ability to monitor, review, and initiate a response. In AWS, you can automate the creation of trusted environments of conducting deeper investigations and forensics. You can run incident response simultaneous and use tools with automation to increase your speed for detection, investigation, and recovery. By automating deployments and maintenance, you can remove operator access to reduce your attack surface area. What is fifth? Protect data in transit and at rest. Okay. Safeguarding data is a critical piece of building and operating information systems. AWS provides services and features that give you several options to protect your data at rest and in transit. Safeguards include fine-grained access controls to objects, ability to create control encryption keys used to encrypt your data, ability to select the appropriate encryption methods, integrity validation, lifecycle rules for data retention. Classifying your data into sensitivity levels by implementing a tagging schema can help you manage protection. Constructing mechanisms to protect data in transit, such as using VPN and TLC connection, is also security best practice. The sixth one is prepare for security events. Even with mature preventive and detective controls, you should still put processes in place to respond to mitigate the potential impact of security incidents. The architecture of your workload strongly affects your ability to prepare effectively during the incident. Isolate or contain systems and restore operations to a known good state. This preparation puts tools and access in place ahead of security incident. Then you can routinely practice incident response through game days. This principle is an integral part of AWS well-architected framework. Minimize attack surface. Generally, a cyber attack concludes for two reasons. Either the attack exhausts themselves and give up, or attacker achieve their goal. Be ready to scale and absorb the attack, minimize it, or remove the possibility of an unprotected device. Certain AWS services like AWS Autoscaling and CloudFront, Amazon CloudFront, give applications the ability to scale to absorb common infrastructure layer attacks. These techniques can also allow you to absorb larger volumes of application layer attacks. This is shared responsibility model. It's good to have this graph in front of you whenever you need it. Customer responsible for security in the cloud. Customer responsible in the cloud. AWS responsible for security of the cloud. Customer is responsible for customer data, platform, applications, identity, and access management. Operating systems, network, and firewall configuration. Like client-side data, encryption, and data integrity authentication, server-side encryption, file system or data, network traffic protection, encryption, integrity, and identity. AWS on the other side, AWS is responsible for the software, compute, storage, database, networking, hardware like regions, availability zones, edge locations. These are the physical parts of the structure. The shared responsibility model illustrates who is responsible for overall security in the AWS cloud. For more information, see shared responsibility model. It's good to read more in depth. Okay, AWS is responsible for protecting the global infrastructure that runs all the services offered in the AWS cloud. This infrastructure comprises the hardware, software, networking, and facilities that run AWS services. I told you this part as well. Now we are going to go to security terminology. Common AWS access methods. AWS Management Console. This is what I'm familiar with. You gain access to the Management Console when you create AWS. We are doing the same. We used AWS Management Console for our labs as well. This is how we practice. And you gain access to the Management Console when you create an AWS account. The Management Console is a web-based interface for access AWS services. AWS command line interface is a unified tool to manage your AWS services from the command line and automate them through scripts. Software development kits. This I need to learn more about. Software development kits simplify the use of AWS services by providing a set of libraries that are consistent and familiar for developers. This is a new information that I'm happy that I learned today. Okay, security terminology, API call. Everything you do on AWS requires API calls. API is the acronym for Application Programming Interface, which is a software intermediary that makes it possible for two applications to talk to each other. The API call sends an API request to AWS service API endpoint. AWS Management Console. This is AWS CLI, SDK, and other AWS service. AWS Service API endpoints, API interface. Security terminology, authentication and authorization. Identity and access management are key part of information security program. They ensure that only authorized and unauthenticated users are able to access your resources and that they do only in a manner that you intend. By using identity and access management, you define who has access to which resources and outline that can be done to those resources. In this section, you will learn about few of the AWS services that deal with identity and access management. who and what. Are we in the, okay, we are still in the security basics. Who? Authentication in this process of validating if the user is allowed access. The most common method of authentication is using passwords as credentials. Authorization is the process of validating that access the user has, giving someone permission to download a file, providing users with administrative access are same example of authorization. Sometimes in authorization, the most important question is not what can users do, but what can they not do. Security terminology. AWS Identity and Access Management terms. IAM is web service that helps you securely control access to AWS resources. For users, use IAM to control who can use your AWS resources, what resources they can use, and in what ways. This is what we were practicing in the labs. I'm a little familiar with this part. An IAM user is entity that you create in AWS. The IAM user represents a person who interacts with AWS. In IAM group, it's a collection of IAM users. Use group to specify permissions for a collection of users, which can make those permissions easier to manage for those users. An IAM role does not have any credentials associated with it like an IAM user does. Instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs temporary credentials. You may access in AWS by creating policies and attaching them to IAM identities or AWS resources. Permissions in the policies determine whether the request is allowed or denied. Security terminology. Security tokens. Security tokens are software tools that an IT administrator can use to grant trusted users temporary and limited access credential to AWS cloud resources. These tokens are written in JavaScript object notation and are called JSON web tokens. For example, when you sign in by using a user pool, Amazon Cognito gives you the 3 GWTs. These tokens are JSON web tokens. These tokens are passed along to authorize access to application resources. Identity tokens, access tokens, and refresh token. Now this module is completed and we are going to study the next session. It may have the lab as well, but we will see. I will see you in my next session. Bye.